Okay. May I start? I'm sorry, I can't. I'm not seeing if everyone is seeing what I'm presenting.
I can see your presentation, Marlon.
Yeah, we can see
Okay.
the presentation.
Okay, thank you very much, people. Okay, let's start. So, here we are, the Sanitation Center as one of the main structures of the Mars mission. Okay, since it's gonna make oxygen, it's generating oxygen, it's gonna generate and recycle water, and we'll deal with the waste management and the air treatment. Okay, all these processes are, as you know, essential for life in Mars. Without them, everyone would be dead. So let's start with the oxygen generation, okay? Without the oxygen, everyone knows, a few minutes and we die. So this is the main process to everything else for colonization Mars, for our mission. So NASA has been working in a machine called MOXIE. It's a Mars Oxygen In Situ Research Utilization Experiment. Okay, here you can see um, a chart showing every step of the machine of the process. Okay, initially the intake, it's the Mars atmosphere. As we know, the Mars atmosphere is something about 98% of CO2. Okay, so we acquire the CO2, we compress it, and we pass it through solid oxide to electrolysis. With that, we can produce O2, which which will be essential for life. Okay, once it's ready, the O2 and the CO will be the byproducts. They will be splitted, and the O2 will be pumped into the station, and the CO and CO2 will be pumped outside back to the Mars atmosphere. And this will be one of the main processes that will be used to make oxygen for us, okay, for us and for the plants, for the whole station. As you guys can see, here's the prototype. The idea was this prototype to go to Mars in 2015. 15, I can remember very well, but it was gonna be there, but there was some problems. They couldn't put in there, but there's a lot of tests in NASA. They're trying to guarantee that this will work. Okay, it's for now just a prototype, but with very high hopes. Following, the next great step for the sanitation center is the water. Okay, as we can all know, as we all know, water is life. So a human can survive only a few days without it. And now we have a number problem. Okay, here in Earth, the average human can consume 36 to 500 liters of water per day. Okay, in ISS they used to consume about 11 liters of water per day. So I was reading a lot in Mars for Many, a website, and they estimate that something like 20 liters of water would be necessary per person per day. Okay. In other articles, I saw 100 liters or something. I think 20 liters is a small number, a number that we can talk about, we can manage to work, at least for the beginning. For ahead, we can think about more and more and more as the quantity of people will increase. We could increase the produce of water, okay, the generation of water. So how do we get this water from Mars? We could send some H2 to make the oxygenation, the oxiding reaction. That will make water for us. Okay, since the O2, the H2 is a very small particle, a very light particle. We can start with that and generate water. But that's just a shortcut, okay? There's not that's not a long-term solution. A good long-term solution would be we stay in a position near to the Martian ice caps. Another way is to extract water from the soil, and a sustainable way is to recycle water in a closed loop for life support, as NASA has been researching and actually using in the ISS. Okay, so let's see first from the soil. Let's imagine that our location site is not so near to the ice caps, so we can't extract directly from there. We could make a well and reach to the ice under the surface of Mars. Okay, we can see in the photo that we have some leads that take us to think that Mars there's a lot of water. The estimates say that the water in the Martian soil is between 4 and 20%. And once we get the soil, we could pass through a pressure valve, passes CO2, high pressure, some heat, and the other side the water will flow. Okay, this water will be with a lot of salts and will be needed to distillate it. For now, it's okay. So the other way is to heat up the soil, just heat up. The water vapor will go up, will go out. Once the vapor, once we have the water vapor, we can treat it and extract just the water, taking out the salt with the desalination center. Okay, with desalination. Another way is to reverse osmosis. Okay, as you can see in the GIF, the reverse osmosis utilizes a membrane that can let pass the fresh water and storage the salt, not letting nor salt nor another particles to pass through it. It's basically a filtering mechanism. Okay, let's go further. And to close it up, we have the recycling water with a closed loop life support. Okay, we get the water from urine, from the waste, from the evaporation of the plants. We pass it through the ducts, goes to the urine collector, to humidity condenser, Okay, and the urine we can centrifuge and heat it up. Once we centrifuge and heat it up, the water, the clean water, will come out. The salts will be stored. Once the salts will be stored, we can put it out to the Martian soil or in a facility just for the waste, the salt waste. Okay. Once we have the water, we have to think about the waste treatment. Okay. All of the poop, all of the poop that we will produce, we will have to recycle it. Once we have the poop, NASA is working on a technology called Vortex. It's a vertical oxidative reactor technology experiment. The main idea is to burn the ash, burn the feces, utilizing a lot of flows of air that will make the whole example to burn. Once it is burned, the water will come out. We can reuse this water, and the ashes that will stay there, we could use as fertilizers. Okay, that's where we can reuse our waste. That will be plenty. That will be very necessary for the long term of the astronauts in there. Um, Another use for this system is for the parts of the plants that we don't eat. The inedible parts could be used to burn to make more fertilizers for the plants. Okay, helping this way the greenhouse. Speaking of which, one way to make more efficient this facility, the sanitation facility, is make it very near to the greenhouse. This way the water won't be, for some reason, wasted in going to one place to another. Once we have the waste treated, we have to think of the air. The air treatment will be very important in this situation, since we have to keep the air breathable, and not just breathable, but in a good condition to everyone to feel comfortable to make their own jobs. Okay, in the ISS, they use a lot of ducts to ventilate the air. And in junctions and main points, they put sensors, they put humidifiers to control the humidity, and also sensors of CO2, sulfur, and all of these sensors to make our experience a little better. So temperature, sulfur, CO2, humidity, and a lot of other sensors that I'm not remembering right now. The main idea is to go to all the sensors to the sanitation center, and once they go there, we can monitor the whole facility. Okay, point to point, seeing if there's any problem. Once we realize there's a problem anywhere, we go exactly there to see with more equipment in hand to verify what is the problem, what is causing, and solve it. Let's see, the quantity of astronauts necessary and their positions. As I can see, we will need a mechanical, a data analyzer, and a chemical engineer. Okay, a mechanical, we will deal with a lot of machines that will need to cleaning to routine to repairing the repairs, and this mechanical will be the guy for it. Okay, as you can see, to the duties of the mechanical, he will perform daily routines for cleaning and repairing on the machines of the facility. Not just this facility, but he will be exclusively for this. Once the sanitation center is so important for the oxygen and the water and the waste management, I believe at least that he'll be full. The chemical engineer will be necessary exactly to understand the processes, the catalytics that will be necessary to make water and to make oxygen. The temperature of the machines will need some repair or some adjust. He will be the guy for it. And for the data analyzer, that I think that will need to be the sanitation chief. In this case, would be me. The data analyzer is there to supervise the water recovery, to guarantee good performance of the necessary machinery, and supervise the levels of CO2 and other waste gases in the station. The idea is that the sanitation chief would be in charge of everything, so he needs to make a report every day to show everyone that everything is okay. The levels of oxygen, the level of water, anything, whatever is needed to make the facility working well. Okay, the duties of the positions, we've been through this, and that's it. The whole presentation. Thanks everyone. Sorry I was a little fast. Here's an overview of the site. Okay, and thank you very much for this opportunity. I hope everyone enjoyed it. Professor?